Hello, my name is Libertad Seguada de la Fuente, and the project that I am presenting for the Premio Sapientia is about chemistry, and more specifically, how varying the potential difference can affect the process of zinc electroplating. The inspiration for this project comes from two very different sides of what I've been doing these past 2 years. On the one hand, one of the most interesting topics, but also one of the most challenging for me within my chemistry syllabus was that covering the different type of cells, those being voltaic cells and electrolytic cells, and their respective applications in real life. On the other hand, I very recently developed a personal interest in jewelry, and in doing so, I found that much of the products offered to people my age with our budgets are rather cheap because they're made from metals like copper or steel or iron, which are not only cheap but also less aesthetically pleasing than others. And these metals are later very lightly covered by gold or silver. When I realized this and how quickly these metals wear off and copper begins to peek through, for example, I thought, first off, how is it that we can cover one metal with another? How does this process work? And can this be undone or redone many times? Because this would greatly reduce the amount of cheap jewelry that is thrown away every single year. And that's when I realized that there was a connection between these two things that I've been doing. And that's when I began investigating into how electroplating can be used in a ton of different industries, from the creation of prosthetics for people with disabilities to jewelry or engines for cars or spaceships. So I drafted my method, and basically what I did is I decided to plate an iron key with zinc at 5 different potential differences: 2, 4, 6, 8, and 10 volts. And obviously I repeated the process 5 times for each in order to increase my precision and my accuracy. And what I found is that, as by Faraday's laws, as the amount of electricity or energy being provided by my cell to my system increased, so did the rate at which ions and electrons flow through the electrolyte solution from one electrode to the other. And so because every single key was electroplated for the same amount of time, which was 1 hour, the amount of zinc deposited onto the keys increased as the potential difference increased. However, I think one of the most important and most interesting things that I've learned through the completion of this experiment is how impactful qualitative data can be on the evaluation and the conclusion of an experiment. So besides quantitative data, which I measured by taking initial and final weight of the keys, I was extremely meticulous about recording other phenomena as the keys were electroplating, and I recorded things like hydrogen bubbles or the formation of zinc lumps. And this allowed me to evaluate and see where the sources of error in my experiment were coming from. For example, I included sugar into my electrolyte solution in order to avoid the formation of clumps or to reduce its effect. However, I don't have much experience in this industry, and I didn't properly realize that I had to adjust this quantity for all different potential differences in order to ensure that its effect was uniform. So what ended up happening is that I had these sources of error, and I realized that I was having clumps more so in some voltages than in others, but I didn't know what was happening. And I was only able to properly evaluate what I was doing wrong or what things could be improved or tweaked in my method because I was so rigorous about qualitative data. So those are really, really valuable lessons that I've learned about the scientific method and about how important it is to keep track not just of numbers, but also the entire process of an experiment.